You don't have to be experienced. It's a good way to get to know the area better, focusing on it. And we have to have a note taker. So we'll wait a minute or two, but we do have a fairly full agenda, as I recall. Let's see. All right. All right. Anybody else like to? We do need a volunteer to take notes. So if you have a laptop, you just have to click on the link in the Meetico, which reminds me also, if you are here in the room and you have not yet signed into the Meetico, please do so, because that's how we both do the blue sheets and do the cues now. So you can either use the QR code that's up on the screen, or you can use the link in the online agenda. If you are hearing me and you're remote, you already figured this out, presumably. And then once you are in that, there is a convenient link to the note-taking tool, which is the other thing I'm asking people to do, to please somebody volunteer to take notes, and we don't need necessarily blow-by-blow of everything, just the high points. And the important thing is the high points and the action items. I don't actually know everyone's names now, which is nice to have some new faces, but maybe some of these people would like to volunteer to take notes. Or some of the old people. Anyway, let's do the business first, and then we'll get to that. Hopefully somebody will decide to volunteer. So I guess, Bernard, next slide. Okay, meeting ticks, as I mentioned, make sure to sign into the session using the Meetico tool. You can get there from the agenda or from the QR code. Use that to join the mic queue if you want to say something. And if you're using the full version, please keep audio and video off for your both pickup and playback. Remote participants, obviously you'll want playback, but keep your own video off unless you're presenting or talking otherwise. And if you're remote, use of a headset is recommended, especially because the in-room acoustics for these things can sometimes be not the greatest, especially for me here in the front because I'm behind microphones. So actually, why don't I take my mask off so I'm better in the other direction. All right, so yeah, so if you are in the tool, you use the hand icon to enter the queue. If you're remote and you want to speak, you have to enable your audio. You can also enable your video, which is useful, but not required, but you have to enable audio separately. They're two separate toggles. Okay, next. Here's some links. Obviously, you can't click on them here, but you can click on them if you go to the materials page and find this. Okay, next. About this meeting, we have a link to the agenda, we have a link to the notes. Bernard and I are the chairs. I'm going to keep an eye on the chat, which is the Zulip. And as mentioned, we need a note taker and ideally a backup note taker. So please, somebody volunteer. We will need a note taker. Yeah, I mean, if you want to do, yes, the people that, oh, so Ronnie has said yes? Okay. Okay, you're doing it in the online tool? Okay, Ronnie will do it in the online tool, but it'd be probably good if somebody can just keep an eye on what he does, so catch anything that he overlooks. Just have a backup. All right, so note well. Various policies are in effect here at the IETF. By participating, you agree to follow them. There's patent rules. You agree to be you're being recorded. This will be up on YouTube. We have a privacy statement. A few of these have more detailed comments later on. Next one, participant obligations. If you're doing a presentation, you must say if there's IPR related to your draft. When commenting, you must disclose any IPR your employer controls. and there are sanctions available if you violate this. So A, consult with your lawyer, and B, if you're commenting on something and have IPR, please say so, or bad things could happen. Also, we are under a code of conduct, so please treat everyone with dignity, decency, and respect. If you feel there has been any harassment or any other troubles, please talk to the ombuds team. All right, so we've got a number of documents. Some were published. I think this is a little bit, not just since the last meeting, it's a little bit longer queue, but makes it look better. Our RFC editor queue is looking better than it did. Skip is in auth 48, which is very nice because that took a while. Others, I think, are or at least should be in edit. I think 2 of them might be marked as ref incorrectly, so I'm going to talk to the RFC editor about that. I'm pretty sure the only ref was frame marking, but I will double check with the RFC editor to make sure about that. Next. We've adopted a number of drafts. I think most of these are on the agenda today. So I won't say more about them right now. Next. We have an ongoing call for adoption for viewport and region of interest dependent delivery. I've only gotten, I think, 2 responses about that so far. So if you feel like this would be a good thing to do, please do comment to the list so that we can know that there's a sufficient community of interest interested in this work. Yeah, okay, I think that's all. All right, GitHub setup. We've recently created a GitHub repository. We've added 3 drafts to it so far. There's 2 more that could be added if the authors want. Also, as I was saying, for things that are not yet adopted as working group items, but likely to be, I'm perfectly willing to have those in our organization as well. So just talk to me and we'll just figure out what name to give it and you can import it. There's then a weekly script that updates, that sends emails to the mailing list with changes that have been. That's just, to add that, that's just a repository of Mark Nottingham's, where there's like a JSON file that lists the repositories to send in order to send email to them. So either I can do that or you can do a pull request against him yourself if you want. But when we do that, when we add a repo, we should also add that to that script so we make sure the mailing list knows everything that's going on. Next. All right, here's our agenda. As I said, it's fairly full, so if anybody has any comments or changes that they would like to make, let us know. Otherwise, we will proceed with Magnus and closing the media types registry. Magnus.
Hello. Yes. So this draft was just adopted, and I have submitted a 0.0 version. It actually made a few small changes. They were really minor, just to try to improve some sentences. There's no open issues with the draft itself. I have one. We got some early review on the next slide, but basically, I think based on this is all administrative things, etc. Unless someone has something, I think we could actually start the working group last call after discussion. You have the link here to the GitHub repo for issues and PRs if you have anything. So, but we can go to the next slide. So Ayana did an early review of this draft. They were asking about, noted that draft AVTCORE RTP J2K SCL is defining a payload form, a media type, and included the payload RTP payload media format types registry registration. So the question they were having is really, if this is approved first, would we need to wait, etc.? I assume that we are hopefully on a timeline with this document that will go quite quickly, and that we can adjust the working group documents coming out of this document if they should have it or not, depending on if they are ready or not before, if they go basically to AD before this document or not. So I think we can adopt that and adjust that. So. And based on the actual publication, remove registrations if it's, I should say, too late. So include it up to the date this is approved. Before that, just leave them in, and after it's been approved, you can just remove it from the documents in the process. So that would be my suggestion.
as an individual, I tend to agree. So yeah, I think probably just remove this from J2K, remove that registration from J2K as following the recommendations of Magnus's draft for future work, and then we don't have to worry about it. And so that this would not be a change to your draft. This would be a change to the other draft, right, Magnus?
Yes. Or I'm saying it's mostly a question saying, let's just follow what comes naturally. If you actually have a draft in the late, which is ongoing publication, yeah, you should probably register until this process change has taken effect. But as soon as it takes effect, we can remove these registration requests from ongoing documents.
Yeah. I mean, I think we don't even necessarily need to wait till you actually your draft actually gets through publication, as long as we are pretty convinced it's going to happen. So
yeah.
Oh, can people hear me? Lorenzo was saying my mic is low.
Yeah, it's a bit low. So, but I agree.
Is this better?
Yes.
Okay, good. Sorry about that. Bernard?
Yeah, I was going to suggest, are there any objections to bringing this to grouping less call? Otherwise, we should just put it in the notes and we can start it soon.
Okay, good.
I see no objection, so that's a good idea. So please take notes that we're going to go to work no less call on that.
Okay. And also, we're at the end of the session, we have the discussion of the J2K, and I put a note in there to remove the registration.
Sounds good. All right.
Okay, then I think we're done here.
Excellent. Ahead of time, so that's good. So next, I guess, Mattis, you are up for this. Great. Where's the countdown timer?
Hi. Next slide, please. Last time at the interim, we discussed a pull request that we had before that interim that added some buffering for when you receive RTP packets that have a flow ID that you have no knowledge of because you didn't do signaling before or something, or waiting for signaling still going on. And we got some feedback on that, and now we did one follow-up pull request, which adds a few more details to that and removes a signaling dependency that we had in there, because the previous PR said that something must be signaled or must be negotiated out of band, which is not true, because you can also statically configure stuff, or maybe your endpoint is able to figure out what's the payload in that unknown flow ID, even just by looking at the content without having the signaling first. So we made a follow-up pull request, and the details are on the next slide. So yeah, as I said, receivers might be able to identify what's in that stream, so it may not have to wait for signaling of that flow ID, so it can just continue without knowing it and doesn't have to buffer anything. We added again that endpoints also may close the connection using unknown flow ID, which was the way to handle this before we did the change. So this is back there. No, the only difference is that endpoints don't have to close the connection, but they are allowed to if they want to. For example, if there's no signaling going on or anything, or the endpoint can just handle unknown flow IDs. If the receiver is dependent on the signaling and signaling is used, then we added a sentence that that says signaling should be completed before RTP packets are exchanged, so that the situation that you have a flow ID that you don't know of doesn't happen. But that's not always possible, so we still kept the addition that we added last time that says that endpoints may buffer some amount, but have to limit this amount. And then it's an implementation decision to decide which parts to drop. And if datagrams are dropped, they can just be dropped. But for streams, you can use stop sending for the corresponding streams that the endpoint decided to drop after some point in time. Then there's one new issue that we got, I think 3 days ago from Bernard, which is about RTCP bandwidth limits that we don't say anything about in the draft yet. The issue basically says that we don't have any considerations about this, but for example, retransmissions could occur if you use streams to send RTCP, and that would change the ratio of how much bandwidth you're using for RTCP. And I think that's also true for a few other things that are sent by QUIC that are like the additional QUIC headers that are in there, because I think our FC 3550 talks about how to calculate intervals for sending RTCP based on the amount of bandwidth that we want to use for RTCP. and it includes IP headers and UDP headers. But for Quick, we of course are on top of UDP, so we still have these, but we also have Quick headers in there and other things like acknowledgements and so on, which could be included there too. And we would like to hear what's the working group opinion on this, if our draft should say something about it, and what that should be.
Joining the queue to speak as an individual. I think, you have obviously all you can control is the input to your transport, not what your transport does underneath you. So I think maybe you say, obviously, your RTCP fraction, your fraction of what you send to the quick layer is an appropriate fraction of what you send to the quick layer for RTP. I think that's all you can do. You might also want to say something then about what the relative priorities should be of RTP versus RTCP, because that's obviously also going to impact this if you don't have enough bandwidth. But maybe that's a different issue, but it's probably worth speaking about.
Yeah, I think that's a good point, that the transport is, after you pass it to the transport, you don't have much control over what's happening. Priorities is, I think, depends a little bit on what your quick stack offers you in terms of how to control priorities.
Yeah, I mean, obviously you can only do what your stack does, but you can have general recommendations.
Yeah.
Bernard?
Yeah, I guess two things there. One on the priorities is I've seen differences between quick implementations. Some of them give priority to datagrams, some of them don't. So there's some differences there. But I guess one of my questions was, how useful do we think it is to transport RTCP over streams to begin with? Is this just a situation where datagrams is simpler, and if you have priority, it'll just probably be the easiest way to do it? Or is there a legitimate reason to transport RTCP over a quick stream?
So I think generally I would suggest to prefer datagrams over streams, but in cases where you can't use datagrams because the extension is not available, or you want to send larger RTCP packets for whatever reason, then you might want to use streams. And in that case, I would suggest to cancel the streams, or like reset the stream when like early, so that you don't have retransmissions, because instead of retransmitting that RTCP packet, you probably want to send a new one instead of retransmitting it or having it retransmitted by a quick stack.
Yeah, I think that makes sense. It might be useful to add some text to that effect.
Yeah, that sounds good.
Saad?
Jahed, as individual, I was just thinking, like, is this something that we can retire entirely? Say, like, well, if you are using RTP over quick, you don't care about the RTCP bandwidth limit.
I think you still care about the RTCP bandwidth, but you may not have as much control over what the quick stack is.
That's the problem. That's where I think, like, if you don't have control, especially for this stream case and all this thing, so can't we just not try to have control and say, like, okay, this is something that not really useful. You periodically send whatever report you produce, and then you put it on next to quick stack, and the transmission is over there, because this will be completely depending on, like, whether you use a datagram and a stream. And then if in this first version, like in this current effort, we would like to dwell and discuss all the potential possibilities, that's a huge discussion. So I was thinking, like, maybe we can have an easy way out, not to care about this RTCP bandwidth, just to focus, like, what are the information you would like to share, transmit.
Yeah, I think that makes sense also, because we tried not to, like, change the rules of how to calculate RTCP bandwidth and so on, or when to send RTCP. So not caring about that may be a good idea, but I think I would also add what we said just before, that you probably prefer to send RTCP over streams and then cancel the streams, or send datagrams in the first place.
Yeah, okay.
Thanks.
Magnus?
Yes, you have to be careful, especially if you consider that you might have middle boxes and have different legs that are interconnected to RTCP. Because you're going to end up with a situation, the question of, are all your timers, etc., based on the bandwidth you configure on how often you can send, etc., and how often you time out? Those aspects need to be considered. So unless you ensure that you have correctly configured minimal distance, etc., and especially for regular non-early traffic that you would otherwise send much more of if you could just increase the bandwidth. So I think you will have to be careful here on how you configure your RTP profile. If you do this just with an AVP profile and doesn't, you would just increase your bandwidth usage. You just send regular RTC more often too.
So the retransmission would increase the bandwidth usage, or what do you mean?
No, just by the regular RTCP sending rules for an RTP stack would try to, if you tell it you have more bandwidth, it will try to use the bandwidth according to its rule for how often it would send regular. Unless as long as you don't have the minimal, it depends if you have the minimal or if you reach the minimal interval, etc. So that's where you have some concerns. I mean, RTCP is built on that you don't have feedback about RTCP traffic going through. And this here you actually know about your RTCP packet if they've been delivered, etc., because Quick could actually tell you if an RTCP packet has been delivered and all those things. But that's on RTCP scheduling level. This is not knowledge it has. It's also you need to remember the fact that you might have multiple hop, and that packet will be forwarded to the next hop, and so that's why you kind of in a multi-hop situation assume common bandwidth limits and things like that, and common parameters. So I think you will have to think through a bit how you write this up so that, okay, is it a strict point-to-point? Do you really know that? And yes, it's only the early traffic in AVPF, for example, etc. You should increase frequency. Or saying you should try to have, say, okay, what's your target and configure that for both endpoints. Otherwise, you will have interesting interactions here.
So Jahed, again, I think thanks Magnus pointing that out. I mean, now I'm putting my Eddie hat on. I mean, one of the things that I would also like to understand, like this is what also triggered my previous individual comment was like, okay, when you are talking about RTP over quick, are we talking about the whole RTP topology, or are we talking about only point-to-point with no middle boxes? Because if this is about whole RTP topology, a terminology we would like to cover with RTP over quick, this will need much work than what we have here. We have done lots of assumptions here, and those are not valid for the end-to-end topology that we have right now in RTP. So that would be something that also I would like the chairs also to keep in mind, having the discussion for like, what is the scope of the uses on ROQ?
Yeah, so
right now it's not clear to me.
We have this section earlier in the draft that talks about topologies, and it basically excludes all the multicast topologies because Quick is end-to-end, but I think you could still have middle boxes, and some passes of that use ROQ and some passes don't, so it's hard to exclude all of it. We have need to think about how exactly or what exactly needs to be. Yeah, that's true.
That's when the RTP bandwidth gets interesting. Yes.
Yeah.
It's not that complicated for point-to-point, but it's for multicast topologies where it gets interesting.
Yeah.
I'm not multi-point, complicated.
All right. Thanks for the input. I think we will try to come up with a PR and share that on list or in the next rendering. Then we have some update on implementation status and interop tests. We have 2 implementations in the draft that are listed since the last update in our new implementation status section, which is the one from BBC, which is a couple of GStreamer elements implementing transport over quick and ROQ. And my implementation, which is in Go, and we have another implementation which is a bit outdated, which I wrote as a proof of concept some years ago, but this one is the current one that implements the recent draft. And then there's a third one from Lorenzo from MeetEcho that we tested at the hackathon. If there are other implementations, I don't know of any yet, but if there are, then please let us know so we can also include them in the draft and also in interop tests. Next slide, please. We're currently doing manual interop tests between the different implementations. We came up with these test cases. I think there could be more, but this is, I think, a good start. We tried in both directions, of course, client to server and server to client, like sending media and then RTCP in both directions. We tried to send datagrams. We tried to send RTP packets as a single RTP packet over one stream. We try to send RTP packets over multiple RTP packets over the same stream. And then something we want to try in the future is, of course, multiple flows and also multiplexing of RTP and RTCP. But the last two are not done in the tests that we did yet. And on the next slide, I have a list or a matrix of what works so far. So of course, I think that all the implementations cover all these 6 test cases, which are the 3 that I mentioned in both directions just now, within themselves. So like my server to my client and BBC server to client and Lorenzo server to client. I have a question mark here in BBC because I didn't confirm with Sam, but from what I saw from him, from his implementation, that is all supported. And I think he sent an update to me earlier this morning, which I think also included the other 2 test cases that I did mention on the earlier slide with multiple flows and RTP, RTCP. Then we did tests between Lorenzo's and my implementation during the hackathon and had some success. The asterisk here mentioned that there were some quick interop issues between the quick stack he was using and the quick stack I'm using. So I think the issues that we had were not actually interop issues between RTP over quick, because we like some parts of it worked, but then we had a problem with after key update in the quick stacks and then it broke. So I think the problem is actually the lower layer there. Once we figured that out, I think it should work as expected. And then we also tried to start doing interop tests between BBC and my implementation in the last weeks, but we had some trouble setting that up properly, so I didn't include that here. But I think we're going to make more progress on that in the next coming weeks. All right. Then SDP, and I think I'm going to hand over to Spencer for this.
Yeah, I'm just doing a quick update on ROC and SDP for
We just
ROC.
had someone enter the queue. Tenji, for Modest.
Let me pause.
Sorry about that. This is not regarding the work you have done. Just you try to ask, have you ever saw something? Because there are some work going with using ROQ to transmit encrypted streams. And then later, I just checked the UDP option part. That means almost there. So there's some proposal to put some sensible information in the UDP option field based on that IETF draft that's going to be published. With ROQ, seems to me that field is not being protected by the quick. So have you ever saw something to do something with that?
Yeah.
Just ask some opinion. It's not like challenge this one. Yeah.
I know about the work with UDP options and that you can put things in there to mark packets. Here it will be protected, of course, because it's quick. And I have not tried or done any work on that. So.
Okay, sure. Thank you.
Yeah, as I said, I'm Spencer, and just providing a quick update on ROC and SDP for ROC. We got excellent feedback at the interim. Thank you all for that. And spread over the ROC and SDP ROC sessions at the interim. I've been through the minutes, comparing them to YouTube, and we've gotten more excellent feedback from Sam Hurst in GitHub. Sam is the implementer for the other implementation that's listed in the draft right now. My focus has been on the seam between ROC and SDP ROC. There are 2 issues one's in ROC and one is in SDP ROC. And that's what I know right now. We are getting people who are helping, and that is certainly welcome. We're not through, and that's certainly true also. Next slide, please. So our next steps for ROC are continue interop testing and prepare for working group last call on this specification. And for SDP over ROC, we continue specification work. The goal is to have a relatively complete -00 by the next AVTCORE interim that we could discuss it there at more detail.
Sounds good to me.
Is there a queue?
Nobody's lining up to talk.
And
Modest, did you want me to
are you coming up for the next session? Okay. So Magnus is not getting in line for questions, and I will sit down and
Yeah, that's so. Yeah, I think we,
2 minutes early.
yeah, we look forward to seeing your draft. Thank you. All right.
All right, I have another draft related to RQ, which is about QLog event definitions for RQ. Next slide, please. For those who don't know QLog, it's a structured logging format for network protocols that's developed in the Quick Working Group. It provides an extensible structure for logging of network protocols and allows for easy sharing of the data independent of the serialization format. There are 3 drafts about that in the Quick Working Group. The main one is the Quick Log main schema, which defines the key concepts like formats of the logging, files, events, and extension points. And then some generic event schemas for use by additional specifications for specific protocols. And the schema itself is independent of the serialization format, so you could use CSV or something that's popular is, I think, JSON sequences. So you have JSONs separated by a sequence marker, a record marker. Then there are 2 additional drafts which define concrete events for protocols. One is for the Quick protocol itself, and another one for HTTP3. Next slide. And similar to the one for HTTP3, I now wrote a draft for events for QLog, for ROC. This includes 5 events, and each of these events has a few metadata that we can include there. So the first one is ROC stream opened, which means that a stream has been opened with the flow ID and a stream ID, and these 2 values are included in the event. And then the stream can be used for multiple RTP packets. That's why we have this event for stream opened. Then we have 2 events for stream packet created and stream packet parsed, which are one RTP over Quick packet was put into that stream, or one packet was read by the receiver. And these events include a ROC packet, which we'll see on the next slide, and a stream ID, which is the stream ID of the Quick stream underneath. And then there are 2 events for datagrams, which are the same, but they don't have a stream ID because datagrams don't have a stream ID. Then the ROC packet, which we saw earlier for the datagram and stream packet created and parsed events, includes the flow ID of the ROC flow and the length of the packet. For datagrams, that's clear from the datagram, but for streams, that's part of what is being sent over that stream because the ROC format uses that length field in front. And then there's a type for ROC application error, which can be used in the Quick QLog events for example, for stream reset or so on, or connection closed. And these are just the error codes that are also defined for RTP over Quick. Next slide. There are currently 2 issues. One is to consider adding useful RTP or RTCP header fields, which might be useful in debugging because that's currently not included. We could either add specific fields from RTP or RTCP to the events, or we could a field that has raw info, which means that we put a byte string in there. That has some privacy implications though, but it could be truncated, for example, to just include the header. I'm not sure what's the best there, so I'm looking for input, maybe from implementers or others who are interested in this. What would be useful for debugging to include from the RTP header or RTCP header? I excluded that in the beginning because I thought maybe this should be in a document called QLog event definitions for RTP, but I think maybe it may be too much effort to write QLog definitions for all the protocols and just easier to include it here. But for that, I would like to keep it to a minimum to what's useful. And then the second issue that I haven't opened yet, but for which I will open a PR later, is that we have to update to a new extensibility scheme, which was introduced in the last QLog version, I think 2 or 3 weeks ago. Next slide, please. So next steps, these events that I present here are implemented in my ROC implementation. I did some interop tests with tooling at the hackathon with tooling from Lucas Pardew from Cloudflare, who was able to parse and read these QLogs that I produced with the implementation. We didn't do any analyzing yet, but at least he was able to parse it. And then, yeah, I'm looking for feedback from the working group if the working group is interested in this, and then if yes, if we should have a call for adoption of this.
in the absence of anybody else saying anything, I think if the people who are actually implementing rock stacks think this is useful to them and they agree on the formats, I mean, if it's useful to one implementer, I would not be so enthusiastic to implement. If it's useful to multiple or all implementers, I would say yes, let's go ahead and do it. So if you can get Lorenzo or Sam to say yes, this works for me, then I would just go ahead. I would say let's do it.
All right.
Bernard?
Yeah, I mean, Qlog is really, really helpful for debugging things and understanding what's going on with Quick. So I think it probably would be pretty useful to have this just for the interop testing and understanding what's going on.
Jahed, so I'm thinking like, okay, I mean, this is the same kind of question, like how useful this is. And I mean, is this something that you really, really need for the rest of the things happening on the rock? Or this is something for like debugging and interrupt testing and all those things? Because those are two different things for me, because Qlog is also evolving. I'm trying to push Qlog to a state in the Quick working group so that people actually make it more useful. We're happy to see like you are using this one, but I mean the call for adoption and all this thing. I think we can deal with those kind of later. Like use Qlog how you want to, and make a useful use of that one. Then when we have like understood like what are the things that we're using, we're extending, how useful that one, that would be, then the documentation part will come saying like, hey, do we want to now document this one because of like some reason, right?
Yeah.
So right now I think it's a bit premature to actually call for adoption or anything. Just use it, and I'm very happy to see like you are using Qlog, just for the record.
Bernard?
Yeah, I mean, just debugging things with Quick, I think the Qlog would be useful. You know, as an example, like I've seen interactions between iframes and quick streams. Like if the window wasn't large enough, you'd see the additional delays, and I was wondering like why that happened. And you can get that kind of info out of Qlog. So I actually think there is some enduring value here. It's not just for the interop. Anyway, so I think it is a useful thing potentially. I've actually had to use Qlog to figure things out.
Jörg?
Yeah, you got one might see Qlog a bit as a new flavor of MIBs of some sort, just for active, that kind of get done with every protocol you do based upon Quick, so that you do have a common debugging and also operational interface that could be used for exporting for all kinds of things. So that might be, there may be a more a broader underlying value, surely beyond interop. Not sure whether this is a good comparison because everybody hates MIBs, but
Yeah. Yeah, I would say even if we don't necessarily adopt right away, I would encourage you to keep revving this document as an individual. Also, I feel like probably, as you mentioned, they're still finalizing their extension points in Qlog. So I'd like to have a little bit more of a stable base so we know that we're doing the right extensions, as opposed to them saying, oh no, that extension point didn't work, we're going to change it again or something like that. So maybe like when Qlog hits, you know, IETF last call or something, that would be sort of, then we know we have something stable to build on, so they're not changing things further.
All right.
But yeah, I think definitely this is going to be useful for the implementers to both the interop and debug and going forward. So
Okay, thanks.
yep.
Okay, this is a discussion of the HEBC profile for WebRTC. Wanted to go over implementation status. That's most of what we'll talk about, and one major open issue. So we now have two implementations, one in Chrome Canary 128 and another in Safari Tech Preview 199. The Canary version has advanced considerably. We now support H.265 encode behind a flag. Decode is on by default. This is in web codecs. And in the WebRTC, you can turn on receive and send behind a flag. and that includes support for profile ID and level discovery. There have been some issues with the packet buffer field trial. I won't get into that too much, but basically the issue is with multiple slices and properly depacketizing that. In Safari Tech Preview, there are some limitations to be aware of. If you turn on lockdown mode, which is the super secure mode, it blocks the encoder and decoder. But the hardware encoder and decoder are on by default, and WebRTC receive and send are on default. In Safari, it's a few CLs behind Chrome. So I'll describe what that does to the SDP, but basically it should be synced up in a few releases. All right. So I mentioned these are the flags you use to enable both the encoder and the send and receive. It is capable of encoding temporal scalability with 2 layers. I mentioned the issues with lockdown mode in Safari Tech Preview 199. There's also a bunch of other things that are coming into Safari, which might affect any sample code you write. So be aware that things are still in progress there. Okay, so here's the summary of where we are with WebRTC and the profile. As I mentioned, there's some issues with the packet buffer field trial, not correctly reassembling multiple slices, and also some issues with SPS PPS caching. We've discussed RPSI and handling of that. That probably won't go in. Then in Safari Tech Preview, basically we have it's H.265 is advertised by default, and if you have a receive only M line, you get some additional profiles. At this point, HEVC is hardware only on all browsers, and in macOS the hardware support is very extensive, like 90% or more. On Windows, not so much. And there are some bugs with respect to discovery of the capabilities and the profiles and so forth, which is limiting the ability to successfully SDP negotiate. So here's kind of a summary of what we've got. We have hardware decode is on at least 3 browsers, Chrome, Edge, and Safari. We do not have software decode or encode for that matter. And then hardware encode, we have temporal scalability up to 2 layers in Chrome and only 1 layer in Safari. And then we can receive and send WebRTC in Chrome with a flag, and Safari it's on by default. And then if the receive only, we actually have profiles 1 and 2, so both main and high profile, whereas if it's send receive, it's only main. So a little bit about the SDP that comes out of Chrome Canary. This is what you get with send receive. Basically, you get main profile 3.1, which is the default. And then if it's receive only, you get both main and high, level 3.1. And then what's a little strange is if you use the send only, you actually get both main profile 3.1 and main profile level ID 156. And I'm not sure whether this is real or not. It's a little bit odd because it's basically sending at a level ID that couldn't be received. So I'm not sure how you'd even set up an interop test for this. Because basically, even in receive only mode, you're not going to be able to receive level ID 156. So this, not sure if that's a bug or a real thing. And then in Safari, as I mentioned, there is no FMTP parameter, so it's just kind of defaulting to main profile 3.1. There have been some interop issues actually getting the SDP negotiation to succeed. It occasionally fails. That seems to be more of an implementation bug than a spec issue. But that's kind of where we are at the moment until it gets synced up to the Chrome release. So the big issue we've been talking about on the list is these potential issues with receive only or send only codecs. And the basic concern is that if you send an offer preferring H.265 and then H.264 secondary, and you actually can't send H.265, then you could get into problems if the answer only includes H.265 in the answer. So the answer could expect H.265, you can't send it, and then you fail. So the alternative is to do basically receive only or send only M lines, but that's not a panacea because non-browser endpoints are likely to encounter interop issues. And also we have probably some bugs with set codec preferences. But at least at the moment, it's not clear how important this will be in practice if the HEVC encode decode and the RTP send receive all gets done, then probably we'll be able to accomplish things just with send receive M lines and maybe dodge a bullet here. And we won't know till we get Safari synced up with all of the PRs and test the STP offer answer and make sure it all works. So that's current status. Any questions?
So is it just issue 22 that's blocking this document from being done as opposed to the whole process, or do you want to actually have it working before you go to last call here?
Yeah, I basically want to make sure everything is functioning and there's not some spec issue or something that we've missed. So we're probably not that far away. I would expect maybe at the next interim or at worst 121, we can actually demo full RTP, back and forth, and then we'll kind of know that it all works.
Cool. All right.
Okay.
Guys, let's go on to the next thing.
All right. Hello, everyone. My name is Lena Chaponnière, and I'm going to present the next couple of slides on RTCP messages for temporal spatial resolution. I will do this on behalf of my colleague Yong-Hee, who is one of the co-authors of the draft. Next slide, please. So just as a reminder of what this draft is about, it aims to support the energy efficient media consumption, which is also known as the green metadata feature, which is specified by MPEG. And in this feature, the sender and the receiver exchange metadata for energy efficient decoding, encoding, presentation, and selection of media. For instance, if the battery gets low at the receiver can send metadata feedback to the sender, asking it to decrease the resolution for power saving. And in the draft, this is achieved by specifying two RTCP payload format for two new feedback messages. The first message is the temporal spatial resolution request message. And the second message is the temporal spatial resolution notification message. So as I've already mentioned, Yong-Hee is one of the co-authors, and the other co-authors are Christian Herglotz and Edouard François. Next slide, please. So just to summarize the history of the draft, it was initially submitted in June of 2022. After that, there were some comments received on the mailing list, as a result of which a new version was issued with the following changes. First, new FMT values 11 and 12 were assigned to the messages. Also, there were some duplicated text from RFC 4584 and 5104 that was removed. Also, it was forbidden to use the value of 0 for a resolution or a frame rate. And finally, there was a mistake in the URL for the reference to the green metadata aspect that was corrected. Then in January of 2023, the draft was adopted by the working group. It was later discussed during an interim meeting during which some feedback was received. And as a result, there was a new version that was issued where the title was changed to RTCP messages for temporal spatial resolution. And this is because the draft only covers partial green metadata signals. And then also there was a constraint added that the proposed RTCP resolution change shall not go above the resolutions that was negotiated via SDP, if available. There was a further discussion on the draft during another interim meeting. And as a result, there was a new version that was issued where handling of a request for temporal and spatial resolutions that is greater than what was negotiated in the SDP was added. And then the last version, version 3, was provided in April of this year with no change. It was just to prevent the draft from expiring. Next slide, please. So one of the questions we got when discussing the readiness for working group last call was whether there are papers describing impact and effectiveness of the feature. And the answer is yes. There's been several papers that have been published about the energy saving relevant to the green metadata standard and the proposed draft. And the latest of such papers was published in the IEEE journal for transactions on circuits and systems. Its title is Extended Signaling Methods for Reduced Video Decoder Power Consumption Using Green Metadata. And this paper includes test results with experimental implementations, quantifying the results in terms of energy savings with various codecs. Next slide, please. So another question we got was about the level of implementation and deployment. So there are some experimental implementations, such as the one that was used to collect the test results I mentioned in the previous slide. Also, temporal and spatial resolution changes have been implemented and deployed in both streaming video and conferencing applications. So the RTCP signaling that's proposed in the draft would further enhance the interoperability among the devices. Also, during the work on this feature in MPEG, major chipset vendors have expressed interest in the feature and actively contributed to the work. So there is interest for this in the industry. Next slide, please. And then the last question we got was about whether the authors have completed all required IPR disclosures. So there was an IPR disclosure made by Qualcomm in 2022 on the draft. And then there was another one made by InterDigital in October of 2023. And then the last co-author, Christian, confirmed that he doesn't have any IPR to disclose. So this has been completed. Next slide, please. So in conclusion, to the best of our understanding, all the comments received have been addressed on the draft. Also, there are published papers describing the impact and the effectiveness. And then the signaling proposed in the draft would enhance the applications which are already out there, and there is interest for those enhancements in the industry. And finally, all required IPR disclosures have been completed. So at this point, we would like to ask for working group last call to be started. Thank you.
All right, does anybody have any comments or Javier? It is Javier, right? I'm pronouncing it right.
Yes. Yeah, so I'm a colleague of one of the...
Okay, well, raise up the microphone towards you. You can just pick it up in your hand if it's easier.
It's all right.
Yeah.
Thank you. So I'm a co-author of I'm a colleague of one of the co-authors, and I wanted to just convey that we discussed and we also agree that this is ready for last call from our standpoint.
Okay. Great. All right. Sounds like that probably we should do that. If somebody has any objections, we should go ahead and do a last call on that. And Bernard and I will figure out the timing of that after the meeting. So make sure that's in the notes that we're going to do a last call on this document.
Thank you.
Thank you. Okay.
Hello, I'm Hyunjin Yang. Today I will present about update information for the RTP for haptics. Next slide, please. So this is the status of our draft. So first of all, we moved the draft on the AVTCORE working group GitHubs. It means that you can review and leave the comment on there. And we, as we announced in the last interim meeting, we added text to add aggregation parts and corrected some minor typo and terminologies. Next slide, please. So this is the aggregation packet payload for payload structures. So one is single time aggregation packet. Another one is the multiple time aggregation packets. Next slide, please. And then we also made a minor update to terminology align some terms with the V3C draft. And we revised some sentence to fix typos. Next slide, please. So we believe that the document is ready with no plan for additional update. So we are seeking further review for our draft. And also we think that one of the way is to elicit the review is the working Roscoe. So if there's no objection, so I'd like to ask working Roscoe. Thank you.
All right. Does anybody have any objections or concerns? Otherwise, it sounds like we should, I mean, I agree that, waiting for comments before the working group last call is just, a deadlock situation. So better to ask for working group last call, and if issues come up, then you deal with them. That's why you have working group last call. So that's what I would be inclined to say. So let's go ahead and do that. We'll figure out the timing of that versus the other document, so we don't have to, I know this, we don't have a lot of time for AVTCORE, so we'll make sure we have, don't overwhelm people, but it sounds like we should have queue up both of these things.
Okay, thank you.
Okay. Thank you. Moving quickly here. Harald.
Quickly, for both of these drafts, if you need the MPEG documents, talk to me.
Okay, thank you. Yeah, and probably when we do working group last call, we should send I'll write that down there. Yeah.
Yeah.
Mhm.
So I'm Harald Alvestrand, and at Google we've done some experimentation with RTP header extensions. Now, RTP header extensions have this interesting property that you don't have to register them anywhere because they're identified by a URI. So we didn't have to ask anyone to do the experiment, but once we're getting beyond the experiment stage and other people want to do it, well, people tend to like to have stable references. Stable reference? Okay, let's see where we can get one. So possibly the right solution is to publish the specification in AVTCORE. Or through AVTCORE in the IETF. And since everyone knows that IETF processing means that something will change, well, at least we have a starting point. Or just to indicate that, yes, we have accepted that publishing through the IETF process means that we have to hand over change control. Well, it's always nice to describe what the problem is before you ask people to accept the solution. So the basic problem is that you get a video frame, you get an audio frame. Actually, you get a video frame from two different places. And you want to know in the world's time, real world time, where it is produced, so that we can try to sync them up again. I mean, if you have two clocks, you don't know what the time is, because they're always out of sync, somewhat. And in addition, there might be delays in the system. Delays like from the time you capture the frame to the time you send the frame. Network delays, multiple hop delays through relays. And so none of the existing identifiers seem to fulfill the purpose. So next slide. The very simplest system is when you have a camera and a sender and a clock, all in one system. At least they agree with each other about what the time is. Then you send across the wire to the receiving system that has a different clock. Now, RTP and RTCP have this nice thing called SRR, whatever, which actually allows you to estimate what the round trip time is. And everyone knows that every assumption is false, but taking the RTT and dividing it in half gives you a better estimate of the one-way trip than having no estimate at all. So there's no perfection. Next. Now, things aren't usually that simple. You have a camera on a system with a clock. Tick, 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 tick. It passes its frames to a different system over RTP or over a wire or whatever, which has a different clock, which then forwards the packet to another system with a third clock and get to the receiver at the fourth clock. Now, the RTP thing helps with the estimate of how wrong the clock is between the two last hops. But the end system doesn't have any idea about what happened before that, unless we tell it. Next slide. So we introduce ABS capture timestamp, which basically says, okay, take the NTP clock of the time that the frame was captured. There's a bit of language saying that, yes, you have to estimate this bit if you have built-in delays and so on. Stamp it. That's a timestamp in the sender's clock. Now you send it to the next hop. The next hop estimates just how much it disagrees with what the time is, and put that into something called the estimated captured clock offset. And then send both these values to the next system down the chain. The next system down the chain says, okay, here's an absolute capture timestamp. Here's how wrong he thinks the previous guy's clock is. And I know how wrong I think that guy's clock is. So I can update the estimated capture clock offset so that it's relative to my clock, and stamp that and pass the package on. Now, this goes down the chain, and at the end system, you have two numbers. You have what the originator thought that the capture time was, and the accumulated estimate of how wrong that was compared to your clock.
So this is just a clarifying question. So there's only one, a given RTP packet only ever has one of these clock offset. It's not like each hop adds yet another clock offset to the packet.
Right.
Okay, thanks.
So each hop estimates on its own. In some cases, the intermediate system might not be using RTP at all, or it might have different estimation algorithms, so that it's perfectly legal to throw away this whole kit and caboodle and produce a new offset that says, here's what I think the originating clock was, or how wrong it was. And we even have a short version for the easy case where the absolute capture timestamp and the clock offset is 0, so that you don't have to waste bytes on sending zeros. Next slide. Experience we had with experimenting with this. We don't need to send it on every packet. Usually, the timestamp clock offset estimate, and it's such an estimate anyway, doesn't vary that much. So once in a while, tick, tick, tick. But we don't adjust clock drift at all. We just believe the latest estimate. So we depend on regular updates once in a while. Not too often, not too rarely. And that's enough, in our experience, to get synchronization over diverse paths like this working for our purposes. Do I have a next slide?
No.
No. I didn't put in a slide of what do we do next. So unless I get massive feedback saying this is a dumb idea, you should never tell anyone that you ever considered it. My intention is to put this description into an internet draft and show it to the working group saying, hey, does this look silly? And incorporate feedback when that happens, and then ask what to do next. The alternatives are, as I see it, this is perfectly okay. It's a non-IETF specification. You should just publish it as an informational document with a URI that has identified this extension in the past. This is an excellent idea, and we want to change it. We should adopt it as a working group document and make the changes we want to, and probably change the URI, and then publish it as standard track or whatever. Or there might be an option I haven't thought of in the last 30 seconds. So
We're not going to send, no.
You saw the agenda and then get dispatch. There's so much that didn't make it there. But floor open.
Okay. Colin?
So Colin Jakes. I mean, I'm not sure I found your motivation for this totally compelling. I didn't quite get what you were actually doing with it. But that said, ignore that. That's not a comment. I don't think we should do this. So it might sort of sound like that.
Yeah.
I think there are reasonable needs where this helps makes debugging. We've sort of had experimental, we've sort of had, let me call them hacks that we've done this before. So I think that having this type of information and some way of sending it would be useful to do. I would prefer to see the sort of taken over as a working group document, and probably I assume that you'd be all right with minor changes to, how formatting and things on this, because there's some problems there, right? If you could send the same semantic information in something roughly like this solution, would that be all right, or would you still want to publish something that had no wire changes from what you currently have implemented?
So the nice thing about the way the way extensions are identified is that there's practically no overhead to supporting the old one and a new one at the same time. So
of course you keep the old one and we change the URI. I'm not proposing you reusing the URI or anything like that. Yeah.
Having the IETF converge on a better solution and adopting that once it's arrived is perfectly acceptable.
Okay, I'd be in favor of that sort of path and direction. And I don't think this needs to go to dispatch. It's clearly in this working group. Sure.
Magnus?
Yes. So my, I still, I'm not certain I understand in which cases normal RTCP signaling fails for this case, because if you have the sources, the SSRC is grouped by CNAME, and you have the actual RTCP sender reports with the wall clock time from that system representing an actual clock that you would care about. And if you would use something like RFC 7273 for clock source signaling, you would know which clock that originating system had, or at least measuring that external source towards that local clock and put it in the sender report at that point, the originating combined node. I guess you have systems here which really breaks the chain, or is it primarily for estimating how long the chain is with the different transport hops?
So you sound very much like I sounded when this was first proposed to me. It took me a while to get convinced by the guy who invented this, who is not here, that this was A, needed, and B, possible.
Yeah. So I'm looking forward to the draft, I guess, for explaining the use cases better, I think. So
So I've taken note of needing better use case descriptions.
Yeah. And in addition, in that, I think really get the understanding of why Why do you need the absolute time rather just not the offset maybe? Why you need both? Because if you have the RTCP report for the absolute time that maps to the timestamp to absolute time on the source, I would like to understand why you just don't need the offsets potentially.
That's because that's the multi-hop property and the need to correlate timestamps that come over multiple diverse paths.
Okay, so I think, yeah, you need to explain why the topology and which is one session versus another session and where you would have to do translations. I think that's what comes in here. Okay, thank you.
Yeah, mostly as an individual, I think I'd certainly like to see the draft, but I'd like to see, it doesn't necessarily need to go into a final standard, but at least for the initial drafts, explanations of why the existing RTCP mechanisms don't work, and then on top of that, why this should be a header extension and not more new RTCP information. And,
Where would you put new RTCP?
well, I mean, maybe because there's no way to put for the middle boxes to say anything, and that's fine, but say so. Yeah, I think that the multi-path cases are more interesting. Stefan?
So thanks. I would like to see the draft too. Most of what I was about to say is what Magnus already said. I had one more thing. In MPEG, we commonly have 3 timestamps. We have a capture timestamp. That's what you're aiming at. We have a presentation timestamp, and we have a coding timestamp.
And what
coding timestamp? Basically,
timestamp.
the time when I think the last bit of this frame or whatever entity it may be has been spit out by the encoder. And I think it would be good if you define a syntax there, make it extensible to capture all 3 timestamps, because that was a major to some people, especially to those which run extremely high frame rate and professional applications, was a major roadblock in the past, where there exist proprietary implementations trying to bold those timestamps, or they are sending an MPEG system layer stream for the sole purpose of having those additional timestamps in the bitstream somewhere. Hacks, dirty hacks. So think about that. Thank you.
Thank you. I'm looking forward to having more discussion on the mailing list about understanding why you need it. Yeah.
Ronnie?
I think it's a longer discussion.
In general, I think it's a good idea, but we have to remember that header extensions are not guaranteed to go end to end, because there are middle box in the middle can drop them if they don't understand them. So it's good. I think people suggested here that you also include what's the current way to do that using RTCP, because today, like in video conferencing, lip sync is done using RTCP and RTP, and in order to achieve the synchronization between the video and the audio. So there are mechanisms. I think this mechanism is good, but you should know that why you use that and why you use the other.
Yes.
Anyway.
Okay, so the feedback I hear is looking forward to the drafts. Make sure you describe the use cases, and we'll come back.
Yeah. Thank you.
Thank you.
Thank you.
Next up is APV.
Hello, I'm presenting online. Thanks
Okay.
for having me a chance to present this one. This one is a first draft submitted to AVT to review the RTP payload format for advanced professional video. If you go to the next page, please. So I hope you guys remember that, I have presented this one at the last meeting in person. Sorry for not being there in person at this time, but advanced professional video codec has been developed as a professional video codec, which supposed to provide up to several gigabit PS throughput and very high fidelity compression, which means that it's not really kind of highly compressed video, but it's more like reasonably compressed, preserving all the original quality of the video. And there are several, not several, there are actually many proprietary, professional video codec or measurement video codec available in the market. And we've tested with many popular ones in the market, and we have found that this development is kind of much better than the others. And also we try to make one open standard professional video codec, which could be IPR risk free, so that everybody can just use it for free. And there's a plan for the open source software for that soon in some other organizations. So that draft has been submitted for targeting information on RFC, which we don't intend to bring this one into any of IETF working group or standardization. I think it's not really a kind of good fit for any of unless any of the working groups strongly interested in bringing it there. In the meantime, there has been a 0.1 version has been provided. There has been a lot of various editorial improvement, and there has been a kind of more detailed syntax on the metadata since we need to add HDR10 plus support there. So we are welcoming to any of the review of this one as well at the same time with the RTP payload format draft. Next page, please.
Sorry, just one question is, do you mean you're submitting this to the independent series?
Yeah.
Okay, cool, thank you.
Yeah, unless any of working group in IETF strongly believe this one fit to their kind of charter or interested in bring their standardization agenda. I know honestly we couldn't find any working group actively working on this kind of thing, so we just kind of provide it as an information RFC. That's the rationale.
It's probably the right thing to do.
Yep, thank you. Next page, please. So some kind of basic information to understand the kind of payload format design. The basic thing is the kind of the frame data, which include all the frame level information in self-contained format. So this doesn't have any kind of parameter set or configuration parameter set which stays once in a while for many frame. Some other some other video codec does, because in its mainly use cases for kind of a lot of intensive editing and so on. So which tries to be this standard try to be kind of self-contained frame header and frame data structure. So the frames included frame header and then series of tiles, then optionally metadata or filler data. And then tile means, I think you may also heard about tile in many other video codecs. Tile is a kind of rectangular subset of the frame, which can include series number of macro blocks. And the macro blocks are same as other video codecs. So tile can be independently decoded as long as you have frame header data. So that's somehow kind of parallel processing or low delay processing purpose. Next page, please. So since the frame is self-contained, we're thinking about providing two different modes of packetization. One is a simple mode, so you just start from frame header. So your RTP packet payload start with a frame header always, and continues to whatever your kind of maximum payload size meet, and then just go to the next packet. So there's no rule for alignment of internal data structure of APB stream, except the startup frame header should be always a startup payload header. Another mode we're thinking about is kind of low delay mode, which is kind of providing alignment with a tile starting points. So your tile always start with the kind of RTP payload header. No, sorry, RTP payload start, so that as long as there's a way to get the frame header, and then you have a packet getting one tile completely, then you can just start decoding. So I will explain a little bit later. So if you are in the payload, low delay mode, we are considering to repeat the frame header optionally at the end of packet, so that if you have a kind of one tile completely, then you can use a kind of optional repeated frame header to decode a tile. Okay, next page, please. To support those for RTP packet header side, we don't think there's any special need to amend any payload packet header field. We set kind of marker bit to indicate the last packet of the frame always, regardless of the packetization format. And then timestamp always represent the 2 bits timestamp for the kind of sampling time of a frame, which could be 90 kilohertz clock, like similar to any other payload format. Next page, please. Payload header. Please remember that we have 2 different mode. So the first thing, version number, we are considering 4-bit, 2 bits, version number starting with 0 as this format. And operation mode will have 2 different mode. So a simple mode and then low delay mode, then 00 and 112 mode will be reserved. Next page, please. Payload type, we try to indicate whether this payload contains the first, in the middle, or the last, right? Regardless, depending on the packetization mode, it will indicate the first or last of the frame or tile. Next page, please. Frame header repeated means that this payload or this unit.
Just wanted to briefly interject on the previous thing. I think, if you go back to the last slide, yeah, I think maybe extremely unlikely given the bandwidth you're looking at, but I think, you could 1-1 would mean it's both the first and the last, and that fits the semantics of a lot of other payload types we have. Basically, this tile fits entirely in this packet would be 1-1.
Oh, you mean the when there is a kind of only one packet carrying entire? Okay, yeah, exactly. Yeah. I was also thinking about that, whether should we, support this one.
And then it's just that, one bit is this is the start, 1 bit is this is the end, and
we
do that a lot with a lot of payload formats.
Sure, yeah. So by design, that perfectly fit. Thanks. Yeah. Okay. Frame header repeated, as I mentioned, that for the kind of tile mode or kind of low delay mode, you may repeat the frame header at the end of the payload. That's indicated by this H bit. And then static frame header, as I mentioned, that there's no kind of configuration parameter set and so on. So frame headers are repeated, but sometimes it doesn't change any frame every frame. So we just kind of have a static frame header bit indicating that we're sending the frame header, but you don't have to decode it because it's the same as before if you already have it. And then frame counter is a kind of down counter, how many packets or payload left to complete the frame or tile, depending on the packetization mode. Next page, please. So we're actively working on the also media type registration and SDVP parameter sections and we've been thinking about to simplify the media type optional parameters. So we don't need anything else than profile level ID, because every frame can change their size and width and so on. So we only indicate the profile level ID should be sufficient. And SDP parameters. So we're also thinking that this may not be used for bidirectional communication in any case. The intention of design or kind of intention of codec is for professional use, like a mezzanine codec. So currently we're only having a kind of one-way SDP parameter set design there, and then all the rest of section like congestion control and security will be just kind of standard normal text similar to any other payload format internet draft. That's it for my presentation, unless there are any questions. I mean, we welcome for your review and any kind of comments to improve.
Yeah, I had a question by what you meant by one way. You don't mean like send only or receive only. You mean like declarative STP without offer answer?
Yeah, I mean, sender only. I mean, so we think it's more like there's a one sender and then there's one receiver. That doesn't really mean that receiver could be another sender.
Yeah, well, that's still not declarative STP. It's just an offer with send only or receive only and an answer.
Oh, yeah. I mean, in that sense, it's like an offer only thing. Yeah, in your terminology. Sorry about that. Yeah.
Yeah, thanks.
Stefan?
Yeah, so I think what they are looking at is using regular offer answer where it's just a send only, receive only thing. Yeah, they are not declarative.
Okay.
Now, I just have one thing. Young, are you sure that you haven't filed a single patent on the media specification because there's no IPR declaration out and that's an 01 draft now? I mean, that
Yeah,
would be rather uncommon.
yes, we have not filed anyone, and then we don't have a plan to file any.
That is very generous of you. Okay, thank you.
That was the intention, and we saw that why there are so many different type of formats, and each one has a kind of readers more pattern attached. We thought that it should be improved.
Again, very generous of you, and keep it like that. I hope it stays like that. It would be really a shame if a nasty surprise awaits us 5 years down the road. Thank you.
Thank you.
All right, so I think as a chair, it's clearly in our scope. I would want to see that the ISC has actually accepted the format before we, just so we know that there's a reference we can refer to, or that it's going to be published somewhere else. Other than that, I think once that's happened, we could do a call for adoption to make sure there's interest in it besides the authors. Well, or I mean, maybe even if there isn't. Stefan is shaking his head saying, I think even if there, Stefan, go ahead.
Yeah, thank you. The format specification, which I just looked into, that 50 pages or whatever it is, that thing looks, is that complete already pretty much? Could you hack the codec from that spec?
I think so. I mean, unless at least we have a little bit of plan to add like a depth or alpha a little bit later. But base codec itself is pretty much complete, and then we are working on, as I mentioned, the open source implementation just based on that spec, nothing else.
Okay, so my preference would be to get that into through some process, whatever that process may be first, before we really move on the RTP payload format for it. Thank you.
Yeah, I think as chair, like I said, I'd like to see this being at least in the process of being published somewhere as a stable reference. But then I think once that's happened, we can take a call for adoption. So let it. And meanwhile, you can of course keep updating this, both to keep in sync with any changes to draft and following any suggestions you both have.
Thank you.
All right, and I guess last we have J2K. Is that right?
Hello, this is Pierre. Can you hear me all right?
Yes, but there is some people doing some. Actually, can somebody in the back close the door because of the construction outside? Thank you.
Okay.
All right, yeah, go ahead, Pierre.
All right, if you just want to move to the next slide. So we've received some feedback. Well, first, thanks for setting up the repo. And so we moved the document to the AVTCORE repo, so that was done. And since the last ID, there's been a couple of editorial improvements based on feedback from implementers, but most importantly, we removed one of the media type parameters that allowed multi-tile images to be transmitted as multiple single tile images over independent sessions. And so that was a feature that nobody seems to have much interested and has not been implemented and not tested. And so it's been removed in this second, this ID version 2. Again, this is just signaling at the media type level. I mean, we can always add it in the future. So, and I think all the comments, feedback has been addressed, and the document is ready for last call, which I think we'll request at this meeting.
All right, well, that's a nice and short presentation. Oh, I guess and this is the thing we discussed at the beginning about Magnus's draft. Yeah, I think our conclusion was that this draft should just remove that section about the registry we're closing, and then because we're closing it, and but then yeah. Yeah.
Oh, I missed. Okay, yeah, I was just actually I was getting off my flight. So let's see. So there's let's see, where is this in the draft? Payload format. Okay. Mapping. Where is this in?
I mean, we don't need to do this online, but
Right. But
yeah.
so I see. So there's no more. So let's see. So how do we communicate? So you mean the media type? Go ahead.
There's still the media type registry, but there was a separate RTP payload media format types registry, which was poorly maintained and redundant. And so we're closing that one down and only using the main media types registry. That is the goal of the document that we discussed at the beginning of the meeting, which you can take a look at just if you're.
Okay, I'm not seeing any reference in the document to this payload media format types registry, so that's why I'm slightly.
Okay, so maybe. All right, Magnus, do you have something?
It's the second sentence of section 10 you need to remove. No, 11, section 11. It's the second sentence. So you just need to remove the second sentence of section 11 and then you're done.
Magnus, do you want to just email them the specific sentence so we don't have to try to do this?
Yeah, I can do that.
Okay, thank you. Yeah. Okay, yes. Okay. All right, sounds good. Okay. So yeah, it sounds like let's just do a quick rev with that change, and then it sounds like we're ready for last call on this. So sounds like we have a bunch of last calls coming up, so that's exciting. We're finishing work, but means we actually have to do it. So Bernard and I will schedule that vis-a-vis the other ones. All right. All right, so that's everything.
Well, just before we leave, maybe we should just go over all the action items, make sure we've got everything.
Yeah. Do you want to do that? Do you have the notes up?
Well, certainly we have, I think, 3 last calls. Is that right?
Yeah.
So J2K,
closing the media types and
media types
and
temporal spatial.
Yes.
Okay, so 3 last calls, and an adoption call as well.
That sounds. This is why we have notes. Was there? What were we adopting?
Was that haptics or?
No, we adopted haptics. Haptics is one of the ones we're doing last call on.
Okay.
We had 4 last calls. Is that right? Sorry for not being more. Okay. No, yeah, I think we had 4 last calls and don't have an adoption. Other than that, I think for RTP over quick, they're going to keep working on it. HEVC, you wanted to make sure you had everything working to make sure there's no other issues. Absolute capture time, Harold is going to write a draft. APV, we wanted to wait until the codec spec is done. And J2K is one of the ones we're going to do a last call. So I'm not sure those are all reflected in the notes as they are now, but hopefully we can remember those things.
Okay.
All right. Does anybody have any other business or? Oh, Javier, what do you want to say?
Sorry, just I think there is an ongoing, adoption call.
Oh yes, there's another. Yeah, there's an ongoing. I mentioned that at the beginning, but there's an ongoing adoption call for the region of interest. Is that the one? Or
Yes, I think it ends at the end of this week.
Yeah. Yeah. So yeah, if anybody has any comments, since we have time, if anybody has any comments on region of interest, just expressing interest, I guess, in that region. You can say something now, or Heather mentioned, say something to the list. Because I think we've only gotten 2 expressions of interest so far. I'd be a little more happy with more than that. So also, if you are yourself interested, but also know other people who would be, encourage them to send something to the list also, just so we know that there's more of a community that wants this. All right, I guess that's everything. So we can go try to get the cookies early if you're here. I'm afraid if you're remote, you're gonna have to get your own cookies, but I encourage you to go enjoy the snack and or beverage of your choice. Thank you all for.
Thank you, everyone.
Yeah, and thank you all very much. And we will probably, as usual, schedule an interim sometime halfway between now and the next IETF. So keep an eye on the list for that. Thank you all very much.